Welcome back to All About Shapes. We're learning a lot more about shapes than you ever thought you could know about them. How many angles are in, or the sum of all the angles inside different polygons, right? Or what a regular polygon is. Last time in 8.5 we talked about, we talked about triangles specifically and how you can prove that one triangle is congruent or exactly the same as the other triangle. We found three different ways: side, 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 angle, side, right? If corresponding sides, angles, sides were the same, then the triangles as a total, as a whole are the same. Side, 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 angle, side, and what was that third one? Angle, angle, side, I believe. You can correct me if I'm wrong. We're not going to flip there right now, but anyway, that's a quick review. Let's move on. Today we're talking about transformations. So check this out. What if I wanted, I got a little square right here, be really quick, so, alright, there's my attempt at a square. If I transformed that square, do a little arrow, into that square, we would say not only that it became bigger, but this one didn't just blow up and become bigger and stay in the same place, did it? It became bigger, which we call that a dilation, but anyway, you can learn that in a couple of years in geometry. Which is actually what I'm talking about with my geometry class right now, coincidentally. So, not only did it become bigger, but it moved over. Right? Those are both transformations. The transformation that we're talking about today, though, are reflections. You guys know what a reflection is. And this has to do with line symmetry. Right? So if I was the perfect human, which I'm not, if I was physically flawless, you could draw a line right down the center of my face, and you could scalp my face off like an Indian. Maybe I shouldn't have said that. And you could fold one side over to the other side, and every point of this side of my face that you fold over would map onto this side, right? So my pupil in this eye is the same distance from the line of symmetry as my pupil in this eye. And every point on this side is the same distance away from the line of symmetry as the points on this side. Now my hair kind of throws this off, but whatever. So, how does that look with shapes? Let's check it out. So they're just telling you here that a reflection is a type of transformation. You can transform this blue sickle-looking figure into this red one by reflecting it in an imaginary line, which would be where? Would it be horizontal? That wouldn't fold over, right? No, it's right down the middle here. That would fold over onto that perfectly. Now, we call the new figure the image. So if you're looking in the mirror, that's a reflection of you. And who's the real person and who's the image? Well, if you're looking in the mirror, obviously you're the real person. We call what you see in the mirror the image. So in these shapes, I'm guessing that this is the blue is the pre-image, the real thing, and then it's folded over onto the red one's the image. Okay, makes sense? This star, is this a reflection? Can you draw one line where you could fold it over and it would map onto that star? No, you couldn't. Horizontal, vertical doesn't work. Any slanted line doesn't work. So that's not a reflection. This actually has undergone a rotation and then it moved over as well. So it's not a reflection. Now, where this gets more on a 7th, 8th grade type level is when you are dealing with shapes in a coordinate plane. So of this blue one and this red one, I want you to look at those right now, and I want you to think which one is the image and which one is the real thing. Okay? Is the blue one the real thing and then it reflects to the red, or is the red one the real thing reflecting to the blue? If you thought the red one is the real image, you're wrong. The blue one is the real image, and it's reflecting to the red one because of these little marks this A becomes A prime, we call it. B becomes B prime, and so on and so forth. So red is the image. It's the reflection. Now, this has been reflected over the y-axis. Notice that A is 1 away from the y-axis here, and A prime is also 1 away from the y-axis. Okay, see how that works? Now, if you listed, there's a pattern here. I want you to look real closely. I'm going to zoom in. There's a pattern in these coordinates. Here's the original vertex. Remember, a vertex is a point on a polygon. The original vertex coordinates, -1, 1 becomes 1, 1. -3, 1 becomes 3, 1. -4, 3 becomes 4, 3. -2, 4 becomes 2, 4. What changed in all of these coordinates? What has changed? The x coordinate became negative, didn't it? Am I right or am I right? I'm right. The x coordinate became the opposite. Negative became positive. Now, let's pretend you were starting with this side, flipping over to that. You would start with positive, and the opposite, you'd now end up with negative x coordinates, right? Because here's the x-axis, and this is the positive side of the x-axis over here. And if you flip it over to the negative side of the x-axis, then they all become negative. But that's not what we're doing here. We went from negatives to positive. So, here's where the big blue box comes in with the keys to success for this lesson. If you're reflecting a shape in the x-axis, which is the horizontal axis, right? If you're reflecting it up to the top or down to the bottom, the original, if it's xy, the reflection, you just make the y-coordinate the opposite. Now, don't be confused. Maybe your original here isn't going to be positive something. Maybe your original is -3, -4. If that's your original, you seeing this? Then the x stays the same as x. So your -3 stays the same as -3, but the y became the opposite. So what is the opposite of -4? It is 4. So this would be the vertex of the reflection. Okay, so that vertex, let's say that vertex was z. This would be your z prime. Okay, makes sense? We'll do an example of that in just a sec. If you're reflecting in the y-axis, here we just made the y's opposite. If you're reflecting in the y-axis, the x's become opposite. So guys, are you recognizing something here? Reflection in the x-axis, the y's are opposite. Reflection in the y-axis, the x's are opposite. So it's like opposite, opposite. It's opposite day. All right, let's do an example of this. If the problem told you, reflect triangle PQR in the x-axis, you should think, x-axis, I got to make the y's opposite. So you could list the original coordinates here. PQR. This is 1, 3. This is 4, 4. This is 5, 2. I got to make y's the opposite. So 1, -3, 4, -4, and 5, -2. Just plot those points, and kabam, you got it. You got your reflection. All right. Now, when you do that, guys, when you do that on graph paper or on your little graph you're making yourself, make sure that the new points, you put that little prime mark, okay? Because it's no longer P. You've reflected it. It's somewhere else now. This is P prime. It's like the new P, okay? Alrighty. So, one more concept to master, and then we'll do maybe an example or two. Line symmetry. We already talked about that with my face, but there's line symmetry in so many shapes and things that we encounter. Look at my phone. Is there line symmetry with my phone? No, not really, because If you couldn't fold the Samsung over, that wouldn't work, right? So there's not really line symmetry there. But let's look at these shapes. If you can draw a line through the shape and fold it over on that line, and it would make a perfect, that would fold over perfectly onto itself. We call that mapping onto itself. Then it has line symmetry. So this seashell, that's the only place you could draw a line on that to where it would fold over and map onto itself. Right? There's no other way you could draw a line. If you did diagonal, wouldn't work. Horizontal, wouldn't work. This guy though, this sea star, you could do it 5 different ways. Each one of these, if you visualize folding one half over the other, it would map onto itself 5 different ways. So that has 5 lines of symmetry. This seahorse though, there's no line you can draw to make it have any line symmetry. So let's see if you can recognize any symmetry here. Tell whether the red figure is a reflection of the blue figure. Remember, it's got to be folding. They're going to try to trick you here. Look at number 3. It looks like, you could have maybe a horizontal line here, but if you flipped that blue over down to the red, it would look different, wouldn't it? The body would be up here and the wings would be down here. So that's not a reflection. This one, yeah, that looks perfect, right? This one, now look closely. If you flipped this blue caterpillar over, wouldn't the eyes and antenna wouldn't it be upside down here? So the eyes would be farther down and the antenna would be down here, wouldn't they? So that's not a reflection. So don't rush through this assignment thinking, oh yeah, reflection, whatever, I can, yeah, that's easy. No, they're going to throw some funky shapes your way, like this one. You're going to have to look closely. All right. Let's do one example of, doing pretty good on timer, of graphing a polygon and then a reflection. So, and it doesn't take long. Oh, you can't even see what I'm showing you. There we go. Let's do 13. Graph a polygon, then graph its reflection in the given axis. So 13, we got to graph, let's see, 2, 5, 7, negative y. So it looks like we're doing kind of this quadrant. All right. Actually, maybe I'll go over this way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I don't expect you to label every one of these, but you do need to label, oops, that's not negative, that's positive 1. That's a negative. Sometimes I like to skip like this, but you do need to label some of them so that we know what your scale is, because sometimes you can see graphs that go by 5s or 2s. All right, so B is 2, negative 1. 2, negative 1, that's B. Uh-oh, I didn't leave enough room here. Oh well, we'll deal with it. All right, so C is 5, 0. That's C. D is 7, negative 2. That's D. And E is 0, 6, negative 6, right? 0, negative 6. So here, oh, that's E. Here is my shape. Nice looking quadrilateral, scalene looking. So we're supposed to reflect it in the y-axis. And someone has a little mark in here. If you're reflecting in the y-axis, you're making the x-coordinates opposite. So let's just work with B first. B is 2, negative 1. Well, the x-opposite is negative 2, so negative 2, negative 1. 1, 2, 3, 4, 5, 6, 7. Sorry, this is going to get a little messy, but you'll be able to follow along. Negative 2, negative 1 is right there. There's my B prime. You got it? All right, C, 5, 0 becomes negative 5, 0. Negative 5, 0 is right there. I'll try to make this bigger for you. 7, -2 is -7, -2 right there. And then what's -0? Is there such a thing? No, it's just 0. So this stays 0, -6. So that point just stays right there. So let's draw that and see if that looks like a reflection. Does that look like a reflection? Whoop, in the y-axis? Does to me. Yes, it is. So that should be enough to get you on your way. There it is. Symmetry and reflections. Have a blast.